Just only post only proof for everyone to join. You live near only, no?
Yes, sir.
Next, check out this question, everyone. So, suppose if I ask you what is the reading of a weighing scale will be, so weighing scale reads the normal contact force applied on it. The weighing scale reads the normal contact force, the one that we apply on it. So, for example, if I have a lift and on the floor of the lift, someone trying to join me. So I make few of you admin so that if anyone tries to join in between, if I don't see them joining, you can add them. So on the floor of the lift, suppose I have a weighing scale, and on top of that, there's a person of mass m, and this lift is going upward with him with some acceleration. And we have to figure out the reading of the weighing scale. So we can draw the free body diagram of that man. Just a moment. So what we have is we have a lift going up with some acceleration A, and there's a person standing on a weighing scale which is placed on the floor of this lift, and we have to find the reading of this weighing scale. So the forces that are going to be acting on this man, we have to figure it out. So one will be the normal contact force that will be acted upon him from below. And what else will act? Mg will act. So I can shift the vector parallel to itself so that just it will look nice. I'm just drawing that normal contact force here. And what else acts? Mg, no?
Yeah.
And what really we observe that it is going up with some acceleration A. So something seen going up with some acceleration A, which means net force that must be acted upon him will be in upward direction. So suppose if I have a case where I have to add two vectors and vectors are acting only along x or only along y. So in that case, I can do things like this, no? So in which direction I can tell using laws of motion that he will be having net force upwards. Because in whichever direction I have got acceleration in that direction, he must be having net force. Means whatever force is applied on him, the resultant of all of them will be upward. So why not take upward as positive as a sign convention to write every vector? So what really the net force will be? So normal contact force acting upward, so plus n. Mg acting down, so minus mg. It's like this one. Suppose if I have one vector of length 4 and another vector of length 3, and this side I take you to take positive, the resultant will be how much? 4 minus 3. So similar thing I'm doing here as well, no?
Yes, sir.
So, and that is going to be equal to mass times acceleration. So what we get, n minus mg will be equal to ma. So n will be equal to mg plus a. Now, but sometime if you see some particular kind of question, suppose maybe I'll tell that thing through an example. Suppose if I give you consider mass as 10 kg, g as 10 meters per second square, and consider the acceleration a as 2 meters per second square. So for that, normal contact force will be how much? 10 into 10 plus 2, that will be 120 Newton. But suppose the options I have given, not that. Suppose options I have given 12 kg, 10 kg, 8 kg, and maybe none of this. So I hope you are getting the point here that the reading that I'm getting is in 120 Newton or in newtons, but the options are having kgs, man. What really it means, this kg, or sometime it is may be written as kgf, or sometime it may be written as kg weight. Both are same thing only. So if I ask you, force acting on mass, which is m equals 1 kg, is how much? That is going to be 1 into g. So that will be g Newton. No? So g Newton is equal to 1 kg weight or 1 kgf or 1 kg. Sometimes we write like that. So here, how much is the g given? G given is 10. No?
Yes, sir.
So 120 Newton is going to be equal to how many kg weight? 120 by g.
12 kb.
So it's going to be, so since g given to us is 10, so I will take 12, 10. So answer will be 12 kg, which means the amount of force, the one that will be acting on the weighing scale, will be same as the amount of force that will act on the weighing scale if a person on in ground frame who's stationary is sitting on top of it, whose mass is 12 kg. Got the point? So whatever reading on ground I will have with the object of 12 kg, same reading I'm getting in this case. I hope all of you got the point. If options are in kg or kg weight or kgf, you will know what is to be done. You will get the answer in Newton. You divide that thing with whatever the acceleration due to gravity is. That will be the answer in kg weight or kg or kgf. I hope this point is clear to all of you. Those who have joined late, for them, I'll just repeat this thing in a bit. What really have to do is we have to find the reading of the weighing scale. So the reading of the weighing scale is not always equal to weight of that person. It can be. So suppose if I take a case, suppose in case if you punch a weighing scale, still it will give some reading.
Yes, sir.
It's not like it is reading weight, it's reading the force that we apply on it. What force? Normal contact force. So we have a person standing on a weighing scale, which is in a lift, which is going up with an acceleration A, and to find the reading. So we will draw the free body diagram, normal contact force upward, mg down. So net force must be upward. So we will take upward as positive as the sign convention to find the net force. Because we know resultant net force is in upward direction only. So why not take upward as positive for the sign convention? So net force acting on M is N minus mg, and that must be equal to mass times acceleration. That gave us N equals mg plus A. So if A 0, in that case, the reading will come equal to mg.
Yes, sir.
But every other time it will be something different. So in case if I have a case, when that lift is going down with some acceleration, suppose, I'll copy that thing only. Suppose in case if the lift is going down with some acceleration here, so same exact thing I will do. I will draw the forces applied on him and upward, mg down, and this is going down with A. If it is going down with A, what really it means? It means net force acted upon him in down direction must be equal to his mass into the acceleration. Now, since down direction is the object moving, so resultant force will be down only. So down I will take as positive for the sign convention. And with that, I will write what will be this vector mg will be. Mg is down, so plus mg. N is upward, so minus n. That must be equal to ma. So n must be equal to mg minus a. Here, that a that is given to us, it is less than g. So suppose if A is equal to G, then the normal contact force will be zero. That is what really we call it as a weightlessness, no? Mhm. Now, in case normal contact force is coming negative, what really you will understand? Normal contact force can never be negative because otherwise it will become a force which is attractive in nature, no? It's not, it is something which will be trying to push this object away from him. So the thing is, if normal contact force somewhere you get negative means there is no contact at all. You are writing a wrong equation. You are considering normal contact force when it is not supposed to be applied on the object. If normal contact force comes zero, which means the object is not in contact anymore. So suppose if I assume normal contact force upward and our answer comes negative, means normal contact force will be acting down. But normal contact force on that person applied by the surface on which he is standing upon will not be downward. That surface is not pulling him towards him. Surface is pushing him away from the surface. So how come normal contact force will be down? So if at all this lift goes down with an acceleration more than g, you will not be remaining in contact with the surface of the lift because the floor will be, you will be moving down with an acceleration g, but the floor is going with more than that. So you are not in contact with the surface at all. So considering the force normal contact acting itself is wrong in such situation. So normal contact force coming negative, which means you are considering him in the situation when it is not acting at all. Means contact is lost long before that only. So if normal contact force is zero, means contact is lost. No. Okay. The next page I'll take. If you take a screenshot and later on I'll share this thing as well. Try this simple question. It's like so simple. I don't want to tell so simple question. Then like so simple, they will not be asking it in CBSE also. We've got these three blocks M1, M2, M3 kept side by side on a smooth horizontal surface, and we are applying force on one of the block here, and we have to determine the normal contact force acting between each block. Look this way.
Yes, sir.
Determine normal contact force in between each block. So please do one thing. Try to draw the free body diagram of M1, M2, M3 on your own.
But government college, sir.
Nice, nice. Congrats, no.
Thanks.
In Chennai only.
No, sir. Some out, but my native
But government college, man. Government college is government college.
was my native, sir. So
Nice,
plan there only.
nice, nice. Very nice. Take a text. My hand is like a clean only. So all of you just try to draw the free body diagram. So one thing is sure that all these three will be moving together. So maybe I will assume that both all of them are moving together with it.
It's 18 hours.
So tell me, one force we know already, the one which is acting with this force F. The normal contact force between M1 and M2, suppose I call it as N1, how or in which direction it will act? It will be acting along the common normal. And the surface, these two are flat surface. So what is the common tangent? The flat surface itself is the common tangent. So whatever the perpendicular I draw to that will be the common normal. So the common normal is something which is a horizontal line, no? So it means the force that is going to be acting on M1 applied by M2 must be along the horizontal and must be in a manner so as to push M1 away from M2. And its reaction will be opposite, which again it is in a manner to push M2 away from M1. No? So this force I call it as N1, its reaction also N1. The same way how the force, the one which is acting between M2 and M3 will act in the same manner only. N2, N2. Suppose if you don't know what is the behavior of this normal contact forces, but still you can guess in which direction it must be acting. How? If I ask you, check out M3, it is moving and M3 is moving with some acceleration. How come? There must be some force acting on M3 along the horizontal direction. The force that M3 is having from the ground below, that I'm not drawing it because that is not of requirement here, but in CBSE kind of exam, you must be drawing everything. So normal contact force here, suppose I call it as N dash, here I call it as N double dash, here I call it as N triple dash. What else will be having M1G, M2G, M3G. Things along vertical is of no use, so I'm not drawing it here. But that does not mean that you should not be thinking about that and should not be drawing it in some CBSE kind of exam. No? So suppose if I ask you, how come M3 will get some acceleration in the rightward direction? There must be some force acted upon him in rightward direction. What it can be? If you guess, it will be the force on him, the one which is applied by M2. Suppose I call it as N2. So his reaction on M2 will be leftward. But still, even though M2 being pushed leftward, but still M2 manages to go with some acceleration rightward, means there must be some additional force in rightward direction. What it can be? N1. What it can be, the one which is applied by M1, that is suppose N1. So N1 on M2 is left rightward. So its reaction on M1 will be, so the normal contact force on M2 applied by M1 is rightward. So his reaction on M1 will be leftward. So even if you don't know how this force behaves, but still you can tell how it must be acting by applying some logic like this. Then after that, nothing much to do. We will be writing the force equation for both, all of them, starting from M1. So whichever way the object having the acceleration, we understand in that direction, the resultant of every force, whatever might be acting, will be in that direction. So since the net force will come in that direction, in whichever direction the particle moves, so why not take that direction as positive in your head to write the net force acting on the object? So if I do that thing for M1, we will have F minus N1 equals M1, If I do this thing to M2, we will have N1 minus N2 equals M2A. If I do this thing for M3, we'll get N2 equals M3A. So we get three equations, 1, 2, and 3. So we have three equations, and how many unknowns we have to find? Maybe suppose if acceleration is also to be found, then you will be considering A also as an unknown. So N1 is an unknown, N2 is an unknown, A is an unknown. So three equations, three unknown, totally we can solve. And looking at the equation, you can see, when these equations are crying out loud, add me, add me, add me,
Yes, sir.
So once you add them, you will realize that N1, N2 will get cancelled, no? And if I add them, left hand side will be having F only, right hand side will get M1A plus M2A plus M3A. So why not take common A? So what is the acceleration? A will be F by M1 plus M2 plus M3. And this value of A, I'm going to use it in equation number 1 and 3 to figure out each of the forces. So N2 will be M3 into A. So answer will be M3 into F by M1 plus M2 plus M3. And then if I use this value of N1 in equation, N2 in equation number 2, or else if I use the value of the in equation number 1 directly, I will get N1 to be equal to M2 plus M3. You check that thing into F by M1 plus M2 plus M3. Okay, I hope all of you got this question. It's like CBSE level question, no? Is it not? The thing is, we should not be solving it like this. Nothing wrong in solving like this. And nothing too much special in solving by some other way that we are going to discuss next. But having that idea in your head can be of some use and will be of lot of use in some other chapter. That is something I'm going to discuss it through this question. So all of you understood? Have a look at these equations. Okay, I can take a new page now. Okay, I can take a new page now. Okay. So now I will talk about internal forces. Which force is called as internal force? The one who is applying the force and the one on whom force is getting applied, both are the part of the system. Correct? That would like internal fight, external fight, like maybe Tamil Nadu people fighting with Kerala people, internal fight for water maybe. And maybe India fighting with Pakistan, external fight for the wine. So internal force means the force whose action and reaction both are in the system. The force whose action and reaction both are in the system. And action and reaction forces are such kind of forces which are equal and opposite. A/C means action, R/C means reaction. Action and reaction forces are equal and opposite, and their line of action is same, no? That we have seen in class as well.
Yeah.
So suppose if I have a system and if I categorize forces into the categories which are internal and external, so net force acting on the system I can write down as summation of or net external force plus net internal force, no? Because what can be else? Either people will be of family or not of family. It can't be like middle thing to that, no? Either you are citizen of India or you are not citizen of India. It's not like you are citizen of like boundary thing, like for the no? So now tell me, if I add internal forces, what I will end up adding? I will end up adding action-reaction pairs, and sum of every such pair will add up to 0. So the sum of total internal force will be equal to always 0. No? So this is the net external force. And net internal force is always going to add up to 0. That is something understandable by everyone. Because if I add every pair will have one guy which are equal and opposite.
Yes, sir.
So every pair will add up to 0. So total sum of such pairs will be 0 only. So sum of net internal force is always 0. Now what really I'm trying to tell is, if I come across a case when every object in whatever I am going to take as a system is moving together, then you can do this thing. Not all the time. If I have a case when every object in a system moves with same acceleration. Suppose if I take a case when I have just two objects in a system, okay? So if I have M1, one object, and M2, another object. What are forces that are going to be acting on M1? F1 means net force on 1. That will be net external force on 1. Correct?
Yes, sir.
And what else it will have? Only two persons are there in the system, no?
Internal.
One and M1 and M2. So force on 1 by 2. Correct, no? F12 means force on 1 by 2. So this is the net force on M1. This is the net external force on, and this is the force on M1 by M2. And this I can write down as M1 into A, because I'm considering all of them are moving together, correct?
Yes, sir.
Same way, F2 stands for net force on 2. So net force on M2 is equal to net external force on 2. I write down as F1E. This I'll write down as F2E. F2E means whatever the forces that are acted upon him, which are not coming from the system, coming from something outside the system. So F2E means net external force on M2. And what will be the only internal force? The one which is applied, it's like a family having two members only. On
Why?
people, they can fight with each other, one pair only.
Yes.
So what else will be force on 2 by 1? And that must be equal to M2 into A. Now what I will do next is, suppose I call it as equation number 1, I call it as equation number 2. Then what really I get? Summation of F1E means net external force on 1. F12. Summation of F2E means net external force on 2. F21. And that is equal to M1 plus M2 into A, no? Then you can tell F12 and F21 are equal and opposite. So this two I will cancel. So what really we end up having on LHS is net external force on 1 plus net external force on 2. Together I can write down as net external force on this system, no? And that will be equal to M1 plus M2 into A, correct?
Yes, sir.
So whenever I have every object in the system moving together, so I can write down as net external force acting on the system will be equal to mass of the system into A, where A is the common acceleration with which everyone is moving together. So this is of use only when every object in a system that you are considering are moving together. I hope this thing is clear to everyone. If not clear, I am going to take an example, then it will become like totally clear. Because I told this thing in like little bit complicated manner, but anyhow, all of you got this thing or not? And Shunu?
Yes, sir.
So same thing I'll be applying in that previous question. Have a look, everyone. I'll take a new page. So whenever you have every object in a system moving with same acceleration, then in that case, you can write down net external force equals mass of the system into it. And in such cases, you will not be thinking at all about the internal forces, the forces that they are applying on each other. Okay, I'll take a new page. And same thing I will draw here. Because in this app, if I paste something now, it crashes everything. Forcing me to draw things again and again. Suppose if the job is to find the acceleration of these three blocks and they are moving together. So that is the only thing I have to find. Then why I will draw the three-way diagram of all of them, since all of them are moving together, no? So what really you will do, you take all of them as one system. So if I'm going to take M1 plus M2 plus M3 as one system. So mass of the system will be equal to M1 plus M2 plus M3, correct?
Sure.
And tell me, it will be moving, all of them will be moving together with A. So what is the net external force that acts on the system? In writing that, I don't care about what force M1 applies on M2 or what force M3 applies on M2, nothing like that. So net external force that acts on it along horizontal is F only. And that must be equal to mass of the system into A. So what really A is F by total mass of the system, and what really it will be F by M1 plus M2 plus M3. So what really you must be thinking in your head. You'll be thinking as if you're solving a question where I have just one block whose mass is M1 plus M2 plus M3, correct?
Yeah.
And on which only force acted upon him is the external force. So whatever the acceleration such one block will have, or such one object will have, that much acceleration every object will have in this thing, which is in which I have taken M1 plus M2 and M3 as system, or everyone will be moving with that acceleration with whatever this one single block will move. I hope all of you got this thing. Suppose like without writing or with writing least number of steps, I have to figure out the normal contact force. Then what I will do, intentionally, I will take few of them in a system or some of them or one of them in a system. Suppose if I have to find normal contact force between M2 and M3, for that I don't have to draw the FBD of every one of them, no? Just I will draw the FBD of M3
Yes, sir.
because M3 has only one force applied on him, the normal contact force from
And
M2. So M3 is the only force, the one which is acting on not M3, we call it as N2. N2 is the only force acted on M3, and M3 because of this force moving with A. So what N3 will be straight away, so what I'm getting writing, not M3, it is N2. So N2 will be M3 into A, and that A we can find orally.
yes, sir.
Next, suppose if job is to figure out the normal contact force between M1 and M2. So intentionally, I will consider M2 and M3 as a system. Why? Because if you don't do that, it's totally fine. If you can do that, it's like little bit faster. So tell me why I am taking M2 and M3 as one system, because finding this force which is acting on M2 applied by M1, which is N1, will be a lot more easier, no? Because if I take M2 plus M3 as one system, what is the nice thing happens is the net external force on this system is the force, the one that I want to find, no? What is the force I'm interested in finding is N1. And N1 is the hero of this system. Got the mind, no?
Yes, sir.
Got the mind, no? So N1 is the guy here who is giving the acceleration to the system. So what N1 must be then? Mass
Yeah.
of the system, which is M2 plus M3 into A, and that A you can find orally. So finding N1 and N2 can be also done. orally, but you must be knowing this concept. So that's why to finish syllabus properly, it takes so much time. I could have left you there only, not like here only. Then question done, but not done. No, if this thing is not done. I hope this point is clear to everyone. Why we take some objects in the system, some objects not in the system. Just it may be convenient for us to get something out of that. So to find the acceleration, I took all of them as one system. To find N2, I took M3 only as our system. To find N1, I took M2 and M3 as our system. I hope it is clear to everyone. Amit, got it now? Got it now? Okay. Got it. I'll take a new page because we are in normal contact force only, man. One class over normal contact, it's not over. So I'll just get doing questions. I take new page. Next, we are going to talk about is string tension. Yeah, how to unmute the mic, man? I don't know. You try. Yeah. I can't unmute your mic. Okay. Okay, I'll take a new page. The next thing that we are going to talk about is string tension. But before that, I must tell you there's something called massless object. This is some concept that we use in this chapter, not like really you have massless object lying around in real life. No. Suppose if I try to apply laws of motion to for an object which is having no mass. And if I write F equals ma, and if I use it to find acceleration F by m, if m is something which is tending to 0 or 0, the acceleration will be tending to infinity. So what is the problem with that? When I say this theory is correct, when the prediction or whatever the answer the theory predicts, same must be the outcome of the out of the experiment. No? It should not be like way too irrelevant. It may be a little bit different, but it should be near to that. So laws of motion tells us acceleration infinity. But we know nothing can have infinite acceleration, which is totally wrong. We know that with guarantee. Means laws of motion is predicting wrong answer. Means laws of motion is wrong. So laws of motion is not wrong. We are applying it for something which is not really possible. But the problem is we want to apply because I want to do some time we have to have some simplification done so as to reduce the mass. Suppose I want to consider massless object like we are adamant. So it's like suppose if I am bringing some new people into our country, totally they are allowed, but maybe they should follow the rules of our country, not like they will bring their own Jingalala rules, correct? They should be following our constitution, then maybe you can come into our country. No? Same way here, I can bring a foreign concept to be in use in our universe. What universe in which laws of motion works? Then it should be something which should not be violating the laws of this universe, which is laws of motion. So for making these laws of motion valid, what really, it's not like some big deal it is. For a rule to be valid in physics or maths, what really it means? LHS should be equal to
That's just
RHS. So if I have massless object, then what is the RHS becomes 0.
0.
Then if laws of motion correct, then what LHS must be
0.
0. So got the point? No? If laws of motion is correct. So if I have massless object, net force on a massless object must be taken as 0. Then some other issue will come that also I will talk about. Net force. So it is a foreign concept which we bring into practice. Totally we can bring it, but it should not break the existing rules that we have. So net force on a massless body will be always 0. So then you will ask, so that okay, A will be F by M. Then if I consider force 0, mass also 0, then acceleration will come 0 by 0. It's like so more weird than infinity. But it is good. Why it is good? This thing is called as indeterminate form in mass. Indeterminate form means mass is telling you politely that this method is not going to work to find the acceleration. Means I don't have an answer at all. Means this method will not work in getting the acceleration. Means I don't have an answer at all. Means that is a lot more better than having a wrong answer. Because wrong answer means minus marks. No answer means at least 0. So it is better to have no answer than to have wrong answer. So that is totally fine. So whenever we see massless body, always you will make net force on massless body to be 0. I hope this point is clear to everyone. It's like some theoretical thing. Think about it even if you don't get it in one go. In doubt here, I can take a new page.
So, sir.
Namit was removed from the meeting, man. Why he was removed from the meeting? I did not remove it. Half an hour only remaining. So 2 days, 2 fours is only done, man. Online class is like so much slow. I've taken a lot of online class during Corona time. Okay, I can take a new page now. You don't copy it maybe now, you just take a screenshot. But after the class, you must copy it. Like hardly it will take 15 minutes or so, no? But you must copy it. So then whatever we did in the last class, do you have any load on your brain that you could remember something? No, no. But the one of this way that, no. That's why this chapter is easy. Just I have to tell everything in the class and done. And the J means level will be like so easy, nothing there. Okay, I'll take a new page in case someone needs me to come back to this page, you tell me. We're going to talk about the tension in a string or string tension. First of all, we'll talk about what really the origin of this force is. So if I ask you to guess, what guess you will have? Not nuclear force, no, man. Correct. Not gravitational force. What is left then?
String.
So electromagnetic force only. Because one string is strong, other not strong. Why? Maybe the stronger one has got like more bonds, like stronger bonds or something, which has to do with charge sharing, means it has to do with electrons and all. So origin is electromagnetic. But what really this force is, slowly you will get it. Every time I tell one point, something will get clear. Once everything told, then full picture will be clear. So it is the force applied by a point on the string on a point which is adjacent to it or next to it. I hope the English is making sense. So I make up my own definition, so sometimes it may not be like grammatically correct and all, but I hope it is making sense. It is the force applied by a point on the string on a point which is adjacent to it. So if a point applies a force on a point next to him, then the point who is receiving the force is also going to apply same exact force on the point who is applying a force on him. I hope it is making sense.
Equal percent.
Suppose point A is applying force on point B, then point B also will be applying same exact force but in opposite direction on A. So string tension at a point acts in action-reaction pair. That is something which has to do with third law. So string tension at a point action reaction pair. Before I go further, suppose if I ask you, if I use the word tensile force or if I use the word compressive force, I hope you can guess what it can mean. If I say compressive force, it is something regarding what really the job that force is trying to do. Suppose if I have some rod or something to which I'm applying some forces, which is trying to decrease his length, will be called as compressive in nature. If I apply some force on an object, maybe that force is not successful in increasing the length, but what really he's trying to. Right now, some people trying to do bad things, not successful, but that is not something we check. We check what you were trying to do. And someone was trying to rob someone, not successful, but still he's a robber because he was trying to. So in this case, suppose if I have this set of forces which is trying to increase the length of this object, so such kind of forces whose nature is to increase the length of the given object will be called as tensile in nature. So now the one point I'm telling so that you will become familiar with okay what this guy is. So what this force is, the force one point on a string applies on the point next to it. At any point, it will be acting in action reaction pair. So I write down at any point and add extra thing in there only. At any point, it acts in action reaction pair along the string and its nature is always tensile. Means that I will explain properly. Just you write down this point. So string tension at a point acts in action reaction pair along the string and its nature is always tensile. Means always it will be trying to increase the length of a given segment of a string. So next point is, suppose if every time the string may not be a straight one, maybe it is a curved one. Suppose if a particle is going around in a straight path, the direction of motion is that straight line on which it moves. If particle moving along a curved path, then who will be telling me the direction of the motion at any instant? It's going to be the tangent to the path at that place, correct? So same way here, in case there is something which is obvious here from this only, it acts along the string. If the string becomes curved, who will be telling me how the string is behaving at any point? It's the tangent. So if I have a straight curve, the slope of that curve is whatever the slope of the straight line is. If I have a curve which is curved line, then who tells me what kind of behavior the curve has got at any place? It's the tangent. So whenever things becomes curved from straight, then whatever job that straight thing was doing, same job will be done by the tangent at that place. That is how the pattern is there everywhere. So if the string is curved, then tension at any point acts along the tangent to the string at any point at that point. Tangent to the string at that point. Before I go further, I must tell you, if somewhere it is told that we have got a string which is ideal string. So ideal string means one thing is it should be massless. Another thing is it should be inextensible, means its length cannot be increased. So whenever something given massless, automatically your brain must tell you every time then that net force on him will be always zero. And also, if I have an ideal string, it is something which cannot handle compressive forces. What really I mean by that is, the moment you try to apply a force, the one by which you're trying to compress a string, suppose there's a string lying on the floor and one end attached to the vertical wall, and you try to compress it. The moment you will try to compress it, it has got all the space to get compressed into and will not react to the force you are applying on it, and the tension in such case will be zero. If the string is loose or not taut, the tension will not be there. It's like suppose if you punch a rigid wall, then the amount of hurt you get, you can imagine. Then you punch a cushioned wall, maybe a pillow or something, then you will not be experiencing same amount of force, because as you apply force, that cushion undergoes continuous deformation. The more it deforms, the lesser the amount of force you get back. So if something deforms continuously, then it will not be reacting at all to the force you are applying on it. So same sort of thing here also is going to happen. If it is an ideal string and you want to apply a force which is trying to compress it. Okay, now I can take a new page now. I have to draw a few things. Suppose if I have few persons hanging like that, this black guy, then we have blue guy, then we have this pink guy, maybe one more color, it's enough. Maybe I've got this green guy. So tell me, all of you can imagine like how the forces that are going to be there between each of the person. No? Suppose A, maybe I'll call it as A, B, C, D. So tell me how forces are going to be between B and C. You can imagine, and A and B, and C and D. All of you can imagine that. So D will be pulling C upward, no? So this way will be the force on D by C. So which way the force the one D will be applying on it? Same only. That will be the force on C by D. I hope you're getting the meaning of this way of writing things. F D slash C means force on D by C. And F C slash D means force on C by D. Then tell me how the force will be between B and C. So C will be pulled upward by B and B will be pulled downward by C. So this way will be the force on C by B, and opposite and equal will be the force on B by C. Same like that we are going to be having between A and B. Force on A by B will be down. Force on B by A will be upward. I hope you can imagine how the force that is going to be acting between each of them. Maybe they are monkeys holding on to the tails of each other. And first monkey is like holding to some branch of tree like that. So I hope you can imagine how the force that will be applied by each and every monkey on the monkey which are next to them. So next I have a string like that, which is hanging in the vertical plane, and we have got a block suspended with the help of him. And what kind of string it is? Ideal. So if I ask you how the tension will be acting at any point, suppose if I ask you find the tension, maybe I'll name the sides as, suppose this is A, this is B, these are different points in the string, this is C, this is D. Suppose if I ask you find the tension at C, so whatever the tension at C will be, it is going to be an action reaction pair. Maybe I'll name it as two segments only. Suppose I have A, and be somewhere I have B, and this is C. A is the point where it is attached to the ceiling. is the point where it is attached to the block. Now, at point B, suppose if I consider tension is T. So see how I am drawing the tension T. Two arrows I am drawing, no? Two arrows I am drawing, which indicates the action reaction pair. So there I am drawing two forces. So how these two forces will act? Suppose if I ask you, draw the ABD of AB part separately and draw the ABD of BC part separately. So that two arrows that I have drawn there, that represents two forces, one that are action reaction pair. This is A, this is B, this is B, this is C. So tell me, you can imagine how C and D are applying forces on each other in action reaction pair. Same way here also forces are going to be. On AB, the tension will be acting along this string. So I have only two choices, not like I have so many choices. Tension, I have given the point. String tension at a point acts in an action reaction pair along the string, and its nature is always tensile. You will understand what it means. So I've drawn two arrows indicating two set of forces which are action reaction pair. Now, if I ask you how much force will be acting on the section AB at point B, whatever the T that acts there, either it will be acting down or it can be acting upward. Only two choice it has because it has to act along this string. Then which way it must act? The one by which I am trying to increase the length of AB, downward only, no? Because the nature must be tensile. So maybe I'll draw different color for that. Maybe I'll draw it that wrong one with the different color. So if I consider upward, that kind of force will be compressive in nature, not allowed. And this one will be tensile in nature. So that is how the tension on the part AB will act at point B. And that one I'm calling it as T. So the moment you know how tension acts on AB, how it will be acting on BC, which is applied by AB, will be upward, no? But even you can get that direction directly, the tension that will be acting on the BC at point B can act in only two ways because it has to act along this string. So either it may act down at point B or upward at point B. If it acts down, then that kind of force that is acting on BC will be trying to compress BC, which is not allowed. No, it should be tensile in nature. So if I draw that force upward, then only it is tensile in nature. I hope you got the point. How I have drawn tension at point B on section AB and BC separately. Maybe I'll write one more point here. Tension on any section like BC or AB acts in a manner to try to increase the length of that section. I hope that point is making sense. Tension on any section acts in a manner to try to increase the length of that section. I hope this point is clear. One more thing I'll talk about in next page. These things are easy only, no? Like common sense or not.
Yes, sir.
Suppose you don't know how tension will act on BC at point B, still you can guess without knowing how this force must act.
Exam.
We have mg acting down. How this thing is under equilibrium. There must be some force here. So what I did here is I'm dividing this string from here. And then I'm drawing the free body diagram of the lower part separately, upper part separately. from wherever I have disconnected AB from remaining universe, the point where it is disconnected, it must be replaced with some force, the one which is acting there. So that I have done. Same thing here, BC is disconnected at B. So I'm applying the force that was acting at the point of disconnection. And field forces doesn't require some contact or anything. Mg from Earth will be acting. And this BC and this block together is under equilibrium. Means T must be balancing Mg, or there must be some force to balance Mg. So that must be upward. So tension at point B on BC upward. So his reaction on AB applied by BC at point B will be downward. I hope this is clear in different way also. I hope all of you understood now. Vishnu, understood or not? Okay, I'll take a new page. I'll write one point. Magnitude of tension at every point in an ideal string is same. So maybe I'll prove that thing through one way as well. Suppose if I have a block which is kept on a smooth horizontal surface and it is being dragged on that surface with the help of a ideal string by pulling one end with force F. Suppose this is the end A where I'm pulling it with, and this is some point P, and this is some point C. And I don't know what tension it is going to be at B and C, so I assume them to be different. But whatever it might be, ideal or non-ideal any string, tension will be an action-reaction pair at any point and will act along the string, and it will be of tensile nature, which is there for every kind of string, not just for some string which is massless. Now, if I ask you to draw the free body diagram of this CD part and the block separately, and BC part separately, and AB part separately. So this is our BC, and this is our AB, and this is CD and the block. If you're not drawing the ABD on paper, you must be drawing it in your head. How the tension will be acting. So AB, maybe I'll write the names as well. This is AB, BC, this is CD. So we are pulling the end A with force F. Then tension on AB, the one which is acting at B, must act along the string. So either it can act along the horizontal rightward or leftward, but it should be a force which should be tensile in nature. So only way it can be tensile if it acts leftward. So T2 must be acting leftward. His reaction on BC must be acting
Right.
rightward. Same way here at point C, the tension T1 can act leftward or rightward, but it should act in a manner that it should be tensile in nature. So this way. So his reaction this way. Now tell me, what kind of object AB is massless? So what must be the net force on him? 0. So for net force 0, F must be equal to T2. Then what kind of object this is? Again massless. So what should be the net force on him? 0. So what should be T1? Equals to
T2.
T2. So since they are supposed to be massless, so they're supposed to have net force 0. Because of that, what really you see, the tension at point C and B, which I took some arbitrary point, not like some special point. Like that, any 2 points I select, tension in those 2 points, tension at those two places will come equal because of this reason. The magnitude of tension in the same string, obviously in the same string, not like every string of the world, which is ideal string, the tension will be same. Obviously, tension in the same string, if it is ideal, will be same. I hope this point is clear to everyone. So if a string is not ideal, means having mass, then tension at some point, at tension at different points can be different. Still, I'm not telling must be different. I'm telling
Can.
can be different. Okay. So maybe one question we will do at least so that it is string tension done today. In last class, normal contact force, this class tension force, then spring force will take like 20 minutes, only 1 hour. So this Sunday your chapter will get over. But suppose without extra class, still I will be finishing the chapter. So tell me how fast I will go, no? And or how fast other teachers might be going. It's not like we are wasting time here. I can take a new page. So let's check out the question, everyone. Now what I have given here is a string which is having mass. Suppose if I have a rope which is hanging in the vertical plane from ceiling. Before that, maybe we'll do something simpler too. Suppose if I have three blocks connected by ideal string like train or something and being pulled with force F on a smooth horizontal surface, and we have to find it's kind of same like this question. You see, three guys moving together, but the force that is acting between them is normal contact force. Here also three guys moving together, but the force that is between them is
Tension
string
force.
tension. Otherwise, kind of same only. So find the tension in each string. Every string is ideal. So whatever tension in an string will be, it will be in action reaction pair. Suppose if I consider tension in this string which connects M1 and M2 is T1. Tension in the string which connects M2 and M3 is suppose T2. And if I draw the ABD of M1, M2, M3 separately, you tell me how the forces are going to be acted upon them, just the horizontal ones. So suppose if I disconnect M1 from here and M2 and M3 from here, then whatever part of the string that remains attached with M1 and M2 and M3, how tension will act at those points. So tension at any point in this string will be same because it is an ideal string. Suppose that is T2. And then I'm splitting it from here. See two arrows. One arrow will remain with him, correct? Other arrow will remain with him. Now tell me one thing. How tension T2 will act on the string which is connected with M3. It must act along the string which is along horizontal. But it should act in a manner so as to increase the length of this part, the one I'm showing it with the cursor. So for that, it must be acting leftward, no? Or it must be trying to increase the length of this part, or it should be tensile in nature. For that, T2 must act leftward, so his reaction on the other part must act rightward, or else how T2 must act on this segment should be acting in a tensile manner and along horizontal So which way it can act? Along rightward direction only, M2. So I hope all of you can tell how T1 will act, how T1 will act on M1 and M2. Now suppose if you did not know how T1 will act on M1, still you can figure out. Since all of them are moving together, will move together with same acceleration A. So how M1 is moving, man? There must be some force on him. What force it can do? T1 tension. The string pulling him. So what kind of force the string must be applying on him? This way. So what force will be acting on M2? Reaction. And M2 being pulled backward, but still M2 able to go with the acceleration A. Means there must be a force which is pulling him forward. What it can be,
T2.
the tension T2. So it's reaction on M3 backward. So even if you don't know what is the behavior of the tension forces, you don't have to know to draw the ABD in this case as well. So if I write the force equation T1 equals M1 into A, this one T2 minus T1 equals M2 into A. For third one, F minus T2 equals M3 into A. Just like earlier case, if I add all of them, I get F equals M1 plus M2 into M plus M3 into A. Then A will be equal to F by M1 plus M2 plus M3. Then you can plug this value of the A in this equation so as to be able to find T1 and T2. Or else you can do that thing, the one I did for that 3 blocks moving together to get the answer as homework. No? So what we will do, which all things you will take a system, you decide. Maybe I'll tell you fast. Time also over. So maybe I'll tell this thing fast. So if I'll take M1, M2, M3 all as one system, what really runs in our head is as if I have got one block only whose mass is same as the mass of the system, and the only force that acts is the external force, which is F. So what is the A it will have? Directly I can answer F by total mass, which I write as summation M means M1 plus M2 plus M3. Now, intentionally, I will take M1 as our system next, because if I check out the force T1, that is the only force that acts on M1. So finding T1 will be a lot easier if I take M1 as one system. So M1 into A. Now, if I take M2 and M3 as our system, why? Because if I do some, what M2 and M3, if I'll take M1 and M2 as our system, if I take M1 and M2 as a system, why I'm doing so, you will see now. Then T1 will be an internal force, and only external force that they will have will be T2. No? I hope everyone is getting the free body diagram of M1 and M2 taken as one system. So this two going together with A, so what T2 must be directly you can write down as M1 plus M2 into A. This thing you can see in your head and you can find that A in your head. So finding T2 can be done in head, T1 done in the head. So do you think this kind of things will ever come in the exam? And okay, I hope all of you got this thing. So I said this one, 18th and 19th August. So Ganesh Chaturthi, you will be having holiday in school now, correct? So 4 to 5:30, I will not teach anything tomorrow. No, 4 to 5:30, like 4:20, 4:30 to 5:30. I'll keep doubt class where you can come and we'll discuss doubts. Nothing I will be teaching in case if I keep class tomorrow. Okay.
Tomorrow, not
When Ganesh Chaturthi is there?
27th.
27th. Okay, then 27th I'll do that. I thought tomorrow only.
Next week.
Okay, Janmashtami also. No? Okay, then we'll end the class. Bye everyone. See you in the next class, like offline class mostly.
It's 19 hours.
And it's only recorded from yesterday.
I will send it today. I will send. I thought how we will be able to see today. So today after going on, I'll download and I'll send both the ones together. So you were absent last class.
Yes, I joined halfway.
No problem. We see the record session and you ask me the doubt separately also. Okay. No? Okay. So anyone getting any trouble, we'll discuss everything again in our normal class also. Don't be worried about that. Okay.
Sir,
Okay.
will you send the record? Will you send the recorded video, sir?
Today I will send. Night I will send. Okay. So that tomorrow, then day after tomorrow you can watch and go through it. And don't watch at normal speed. Watch at double speed.
Okay. Sir.
Okay. Okay then. Okay then. Bye.